Hi everyone, welcome to Math. Today we are going to study chapter 6 triangles, exercise 6.2, question 10. The diagonals of a quadrilateral ABCD intersect each other at the point O such that AO upon BO is equal to CO upon DO. Show that ABCD is a trapezium. Here we have to prove that the quadrilateral that we are going to do is a trapezium. So first let us draw a quadrilateral which will be in the shape of trapezium because that's what we have to prove. So we have drawn a quadrilateral ABCD. A, B, C, D. Now what is the property of the trapezium is, in trapezium, any two sides will be parallel. Not all the sides, any two sides. So that means AB is parallel to DC. See the okay, so that's the property of the trapezium. So that's what we have to prove. If we prove that these two sides are parallel, then we can say that this is a trapezium. Okay, so let's see. The diagonals of a quadrilateral ABCD intersect each other at the point O. So let's draw a diagonal. So this is one diagonal AC. This is another diagonal BD. So the diagonals of the quadrilateral ABCD intersect each other at the point O. So this is point O. Such a way that AO upon BO is equal to CO upon DO. Okay. So now what we have to prove? Show that ABCD is a trapezium. So I told you to prove that it is a trapezium, we have to prove that AB is parallel to DC. So if we prove this, then we can say this is trapezium. So let's begin now. Question 9, if you do, is just the converse of it. We are doing it here. Okay. So let's begin. What is given to us? Let's write down. So what is given? Quadrilateral ABCD, in that AC and BD are diagonals. Okay, they are diagonals. They intersect at point O. Okay, that is given to us, and also given to us that this ratio is given to us. Okay, such a way that AO upon BO is equal to CO upon DO. So now what we will do, this we will just make it like AO upon BO, right? AO upon BO. Instead of that, this ratio we will write like this: AO upon OC, BO upon OD. That way we will take it, because then it is easy for us. If this way means we will prove, and afterwards when you cross multiply, we will get back to this. Okay, so we will write AO upon OC equal to BO upon OD. Okay, so if you get it this, then once we prove this, then you can convert it into this form, right? So this we consider is equation 1. Now what we have to prove? We have to prove that AB is parallel to DC. No? If it is parallel, then only you can say it is a trapezium. So ABCD is a trapezium. What we have to prove is ABCD is a trapezium. Show that ABCD is a trapezium. So that's what we have to prove. So next, what we will do? We will do the construction, because we need to draw a parallel line. To get a triangle, if you are taking any triangle, we need a parallel line for that. Then only you can prove that it is either Bpt theorem or a converse of Bpt. So if you don't know, I'll explain to you. So this is called Bpt theorem. ABC is a triangle. If you are drawing a parallel line EF, then if this is parallel, if you are very sure that this is parallel, EF is EF is parallel to BC, then you can say for sure that AE upon EB will be equal to AF upon FC. Okay, so if this is parallel, then you can say these ratios are equal. This we call it Bpt theorem. Okay, so keeping that in mind, opposite is converse. Okay, if ratios are equal, then this line is parallel. Okay, if ratios are equal, if you are proving that these ratios are equal, then you can say these lines are parallel. So here what we have to do, we have to prove that these lines are parallel. So that means converse of Bpt theorem we have to study. That means if this is given, then we have to prove the lines are parallel. Okay, so let's begin now. So let's construct a line like question 9 only. You have to do it. Okay, so we construct a parallel line such a way. So we are constructing a parallel line such a way that that line is parallel to AB also, and this line will be parallel to DC also. So if you are producing this line, this will become parallel to AB also, and this will be parallel to DC also. Okay, so our construction is such a way that OE is parallel to AB and OE is parallel to DC. Okay, we have constructed. So now let's begin the proof. Okay, so let's prove that in triangle, we'll take one diagonal now. If you are taking diagonal AC, okay, let's take diagonal AC. If you are taking diagonal AC, then EO is parallel to DC. So if this is parallel, means this becomes the triangle. So this becomes our triangle. Okay, so in this triangle, if this is a, we have constructed, right? So this is parallel to DC, means then can we say these ratios are equal, because basic proportionality theorem says if the lines are parallel, then the ratios are equal. Okay, so if the lines are parallel, these ratios will be equal. So that's what we are going to write down. So in triangle ADC, EO or OE, whatever you want to write, OE, since I have written here OE. OE is parallel to DC. So by basic proportionality theorem, we can write that AE upon ED. AE upon ED will be equal to AO upon OC. Okay, this is equation 1. So this let it be. Okay, this is equation 1. Similarly, in triangle, so we have taken this diagonal, let's take the other diagonal. Other diagonal is BD. Okay, this diagonal. So if this diagonal you take, then this line is parallel to AB. So this becomes our base. So this becomes another triangle. Okay. So now in this triangle, this OE is parallel to AB. So if these two lines are parallel, means this ratio and this ratio will be equal. So let's write down in triangle ABD, OE is parallel to AB. So by PPT we can say, by the way, this is parallel to this by construction. We have constructed, right? So you have to give the reason how you can say it is parallel. Okay, so by construction. Okay, by Bpt theorem, we can say that AE upon ED is equal to BO upon OD. AE upon ED will be equal to BO upon OD. This is our equation 2. Now look at both the equation. Both the equation you see, Here also AE upon ED, here also AE upon ED. If these two sides are same, left hand side is same means right hand side also will be equal. So from equation 1 and 2, we have AO upon OC will be equal to BO upon OD. So now in this ratio we can say in triangle, this both the triangle ADC and ABD. ADC and ABD, OE divides them into equal ratios. Okay, so this OE is dividing both the triangle into equal ratios. So OE is parallel to DC also and AB also. So OE is parallel to DC and OE is parallel to AB also. How? By construction. So if OE is parallel to DC and OE is parallel to AB also, then can we say that DC will be parallel to AB? So this is what we have to prove, that AB is parallel to DC. If they are parallel, then can we say that it is a trapezium? Thus quadrilateral ABCD is a trapezium. Hence, proof. That's it. Thank you. God bless you.